Right, next one. Figure 11 shows a student launching a toy aeroplane. To launch the aeroplane, the student pulls on it to stretch the spring and then release it. So clearly this is to do with energy, okay, and clearly it's to do with elastic potential energy. So before we do anything, we know we're going to have to use the equation. Elastic potential energy equals half the spring constant times by extension squared, which is there, okay? So I'm going to write that down ready because I know that I'm going to have to use that at some point. EE equals half the spring constant, which is represented as K, times by extension squared. Just before the toy aeroplane is released, the spring has an extension of 0.12 meters. So that's fine, we don't need to convert that. Mass of an aeroplane is 0.020 kilograms. I know kilograms has a prefix there, but kilograms is kept at kilograms. You've just got to remember that's an exception. Spring constant is fine, so there's no converting. Calculate the maximum speed of the toy aeroplane just after it's launched. Use the physics equation sheet. So there is actually, as far as I can see, only one equation with speed on. Well, no, there's two. Okay. There's this one here, distance travelled equals speed but times time, but clearly we haven't got distance, we haven't got speed, so it can't be to do with that. So it can only be to do with this one. Okay, kinetic energy equals half the mass times by speed squared. So what we need to do is write out our C FIFA, knowing that we're going to use that equation there. We don't need to do any converting, and we want to use that equation, which is the kinetic energy one. So EK equals half the mass, that's right, times by velocity squared. Now we just replace the letters with numbers. So we don't know the kinetic energy, okay, but we do know what the mass is. So we want half the mass. So we want 0.020, half of that is 0.010, and we want to times that by the velocity squared, and that's what we want to work out. So that's what we want, v squared or speed squared. They represent it as a v because of velocity, but in a calculation it's the same thing. So EK equals that times by that. Remember, we've already halved the mass. So now what we need to do is use another equation to find our missing kinetic energy. Now we know from this that when we stretch the spring back, elastic potential energy is stored within the spring, and when it lets go, that plane starts to move. So that elastic potential energy is transferred into kinetic energy, because the spring, once it's released, has no energy left within it, because all of it's been converted into kinetic energy. So the amount of elastic potential energy is exactly the same as the amount of kinetic energy. So if we can work out the elastic potential energy, we also know the kinetic. So we go C, which we don't know, FIFA, like that. Now we're going to use this equation because this is the equation for elastic potential energy, and we know elastic potential energy is stored in the spring. So we write E equals half the spring constant times by extension squared. Now we replace the letters with numbers. So we've got E equals half the spring constant. Half of 50, that's the spring constant, is 25. So we do 25 times by the extension, which is 0.12, but it's the extension squared. So we don't need to rearrange, we just need the answer. So I'm going to put that into the calculator now. So we've got 25, which already is half of our spring constant, okay, times by 0.12 squared, and that gives us 0.36. Okay, so it's 0.36 joules. Okay, and that is our kinetic energy. Yes, it's calculated our elastic potential energy, but all that elastic potential energy is transferred into kinetic, so it's the same amount. So we can go 0.36 equals 0.010 times by v squared. So now what we want to do is divide that to get v squared on its own. So what we do is we divide that by 0.010 to get v squared on its own, 0.10. Whatever we do to the right, we do to the left. So it's 0.010. They cancel. Okay, so that gives us 0.36 divided by 0.010 gives us 0.36 divided by 0.010 gives us 36. Okay, now that is v squared. Okay, but we want v. So if we square root 36, that will give us, and we square root it, even though we don't need to, because we know what square root of 36 is, but we'll do it anyway, just to make sure we don't make any silly mistakes. Okay, and then it's 6. Okay, so speed is 6. And we always measure speed in meters per second.